All right, so let's talk about transformation of functions. We're going to say, understand how parent functions are changed by the different types of transformations. Excuse me. So the main focus here is that we want to make sure that we understand the different types of transformations. It doesn't matter the family of functions, so that's what I'm going to kind of really try to stress. Okay? So, let's look at this, shall we? Boom. Okay. This right here is our general format. I will come back to this at the end and discuss like what each of those little symbols and numbers or whatever means. Oops, I should put that as a plus minus, and I almost forgot to do that. Oopsie. There we go. Okay, so now, so let's look at this. Let's start off like this. We're going to talk about translations. What are translations? Well, translations are the C and D. So when you go back to this, we're talking about C and D. All right? So if we go to this, and I'm going to go here, let's look at these three functions. Oh, I should have put more stoppers, but we got it. Okay. So we got this. I'm going to stop right there. We've got the parent function, f of x, x squared, so you can see that in maroon. Then we're going to do the x squared plus 2 in green, and then the x squared minus 3 in blue. So you can see the x squared plus 2 moves it up 2 spots, while the minus 3 moves it down 3 spots. Now, they may look like they're exactly the same. Like we're going to learn how we graph quadratics by hand or get points. And you would see like on the quadratic, it starts at 0 and go up 1 over 1, both to the left and to the right. The next one, the green one, would start at 2 and then go up 1 over 1 to get the next set of points. And the blue one would start at negative 3. So all that does is shift it up or down. Now I'll give you another example, and you can see square root of x. And it will do the same thing. Notice here, it started at 0, then it moves it up plus 3 and minus 2. So when we have the d, which is at the very end, plus moves it up, minus moves it down. And by ever how many that number tells you. So kind of keep that in mind. Now let's look at C. Okay, this one shifts to the left or to the right. So we're going to now go to the left or to the right. Notice how this one will be inside with the x, like inside the parentheses or inside the absolute value symbols, something like that. So you can see here, now pay attention though. This is where you have to be careful. Notice the minus 4 moves it to the right. And the plus 3 is going to move it to the left. Okay, so inside that parentheses, you're going to have to kind of think opposite. Let's look at another version. Let's do x cubed. Okay, the x cubed, remember, x cubed is a curve that kind of does a little funky curve like this, but it goes through 0, 0. The plus 3 will start 3 spots to the left. Plus means inside the parentheses you go to the left. But a minus 5 will go to the right. You're like going, but, wait. Plus and minus moved up and down. Well, kind of remember, inside the parentheses, always think opposite. Okay? So, when we have a plus, we're going to move to the left. When we have a minus, we're going to move to the right. That's fairly simple to keep track of. So, we'll look at some of these hopefully in a minute. Now, let's talk about reflections. Reflections are the negatives. I say at the front, but you'll kind of see. So when you have a negative, like let's say x squared, here's x squared right there. Okay, if you put a negative in front of that x squared, it's going to make it point downward. Instead of pointing up, it's going to point down, which is a reflection over the x-axis. So it reflects over the x-axis. Go back to that, sorry. So this reflects over the x-axis. Now, if I change that and say, do something like this, and think of that as like being inside the parentheses. Okay, instead of reflecting over the x-axis, like here's the exponential function. Now it reflects the other way. It reflects over the y-axis. So where that negative is located, and notice it's in front of the x, but is it in front of the x completely, or is it in front of the x just in that parentheses? And that would tell you what kind of reflection would you get. Okay, so there is reflections. And you got to know whether it's over the x-axis or over the y-axis. Okay, now let's talk about dilation. Dilations are talking about making it like stretch or compress, wider or narrower. Okay, if it's the A, which means it's the number in front, in the very, very front, then it's going to be talking about a vertical stretch or compression. So let's give you some examples. Went back to x squared. Notice I'm trying to change up the different functions, try to mix it up quite a bit. Okay, I'm going to go stop right there. So you can see here in maroon, we've got the x squared, the parent function. Notice that the 3x squared goes through the same origin, or goes through the same, middle point. But it looks like it's kind of squeezed in. That is what is known as a vertical stretch. Okay, it's stretching upward and like towards that y-axis. The 1/3 x made it wider. That's what's known as a vertical compression. It's compressing away from the y-axis. Okay, notice how I'm kind of trying to word that. Okay, so this is one of those that you might want to make sure you definitely have in a note card, because these are the ones that can kind of get a little confusing. But I do want you to make sure you understand stretch or compression. Now, I would say that the green one is that it was a vertical stretch by a factor of 3. You would think I would stop doing this around that time. Anyways, and then the 1/3 is a vertical stretch, compression by a factor of 1/3. We might discuss later that I might change up that wording a little bit, but right now kind of go with that. Okay, now what about the B? That's a horizontal stretch or compression. So here we've got f of x equal to 2x, f of x equals to 1/2 x. Okay, and they do kind of the same thing, but here's the thing. Well, no, I'm going to let that play through. Okay, notice how, horizontal, we're focusing on the x-axis. So we're focusing on the x-axis. Okay, 2x made it like more narrow, but it's compressing away from the x-axis. Whereas the stretch is stretching towards the x-axis. So that's why we say that if the number is bigger than 1 for the horizontal, if we're talking about inside that parentheses, it's a horizontal compression because it's going away from the x-axis. Whereas the stretch goes towards the x-axis from the parent function. Notice the difference in the parent function. So it's horizontal stretch like that. Now here's the other thing you got to be careful about. Traditionally, we've said that when you say by the factor, like going back to here, like when I was talking about I shifted to the left 3, I went to the right 5, that type of thing. But here I said I stretched by a factor of 3, or I compressed by a factor of 1/3. I may even have to say that one's a factor of 3 too, but we'll talk about that later. Here you got to do reciprocals. You're compressing by a factor of 1/2. So do the reciprocal of that. You are stretching by a factor of 2. So again, do the reciprocal. So you have to do the reciprocal when you describe the factor. I mean, it's easy to tell me if it's a stretch or compression, but I may ask you by what factor. All right, so let's look at some examples. Okay, so describe the transformation. Tell me what is this and what's the transformation. So let's look. F of x is equal to 3 times 2 to the x power. Now, obviously, this is an exponential function. And what is 3? 3 represents the A number. Okay? A equals 3. So that would mean that, since it's not in the parentheses or whatever, that this is a vertical stretch by a factor of 3. Okay? The other one, let's do this one, 5x to the 3rd, it's cubic. B is equal to 5. That's a horizontal compression by a factor of 1/5. So notice here how I took the reciprocal of the 5. But it's a horizontal compression. Next one, let's make it a little bit longer. Notice I've got square root now. Okay, notice that these are the C and D's. It's a square root function. C is equal to 3, D is equal to -2. Notice that they're keeping the minus with that. Okay, So this is a shift. The plus 3 means it goes to the left 3. The negative 2 means it goes down 2. And there you go. And then we can talk about reflections and things like that, but that pretty much sums it up. So let's go back to this beginning here and talk about this. Okay, so this is our general format. Keep in mind what these pluses and minuses mean or what they tell us, stuff like that. So if I go to this, and I'm almost done, so kind of keep that in mind. The plus C, let's do plus D. Plus D is the easiest. Plus means you go up or down. Okay, notice that's outside the parentheses. It could be a square root, logarithmic, whatever. Plus with the C, plus and minus with the C. Plus goes to the left, but a minus goes to the right. The negatives here both mean reflection. The only difference is if it's the A one, it's over the x-axis. If it's the B one, it's over the y-axis. Okay, so how does it flip? Does it flip up and down or does it flip around like a twist? Okay, and then if A, remember, the absolute value of A, notice it was the absolute value, is greater than 1. So then when I'm looking at this right here, I'm not looking at the sign. The sign is where I only worry about for the reflection. If A is greater than 1, it's a vertical stretch. If it's between 0 and 1, it's a vertical compression. Okay, so we've got that. I ran out of space, but there you go. B is greater than 1. It's a horizontal compression. If it's between 0 and 1, it's a, horizontal stretch. Stretch. Okay? And do remember that when we talk about the factors, think opposites on the B's. Okay? Do reciprocals. Don't forget about that reciprocal. Reciprocal. Alright? So that pretty much sums it up. I know this is quite a little bit longer than what I normally like to do, but there's a lot of information here. Anyways, thank you so much for your time. Y'all have been such a great class to start off with. Thank you so much. I really do appreciate y'all. And look forward to seeing these notes. Thank you so much. Take care.